5.4, the graph of a rational function. Not a rational functions. That doesn't make sense. That's okay. We'll just pretend that's not there. All right. So if you have a TI-84, 83, or 89, bring it out. So get your graphing calculator out. Okay, I hope you have your calculator. So to graph a rational function, we're going to factor. So there's 6 steps. I know that's like, oh my gosh, 6 steps. They flow perfectly though. So factor the numerator and denominator of r, find the domain of the rational function. So it means factor everything and then find the domain. Write r in its lowest terms, meaning simplify if you can. Find the intercepts of the graph. Use multiplicity to determine the behavior of the graph of r at each x-intercept. So remember, if it's even, it touches. If it's odd, it crosses. Find the vertical asymptotes. Find the horizontal or oblique asymptote. And then we're going to use the real zeros of the numerator and denominator of r to divide the x-axis into intervals. So remember how we graphed polynomials in chapter 5, 5.1? This is very similar to that. We're going to treat it very similar. It's just going to look like a different graph. All right, so let's graph the rational function x minus 1 over x squared minus 9. So our first step is to factor everything. So on top, I can't do anything there. That's just x minus 1. But on the bottom, we can factor that into x plus 3, x minus 3. Okay, so we factored. Now we're going to find the domain. So the domain, remember, its bottom cannot be 0. So we have x plus 3 cannot be 0. And x minus 3 cannot be 0. So we have x cannot be negative 3. And x cannot be 3. So we can write that in set notation if you want, interval notation. But for math purposes, we kind of just keep it this way because that's all we just need to reference back to it. Our second step is to simplify if you can. We cannot simplify this fraction. So since we cannot simplify it, we move on to the third step. The third step is finding x and y intercepts. So we have our first, which is x-intercept. So remember, x-intercept, we just set y equal to 0. But remember, do we have to do that for the x-intercept? See, do you remember how we find the x-intercept of a fraction? We set the top equal to 0. We haven't talked about that in a while, but I do remember in a video, I referenced this. I'm like, I'm going to call upon it again, and here it is. So remember, the y-intercept, it's top equals 0. Why? Because the denominator cancels out. It does. It ultimately cancels out. So you only need to focus on the top. So the top, we have x minus 1. So we have x minus 1 equals 0. So that's x equals 1. So that means our x-intercept is 1, 0. Now, sadly, there's no trick for y-intercept ever. There's like never a trick besides like lines and quadratics. But seriously, there's like never tips or tricks for y-intercept. We just have to find it. So to find it, we make x equals 0. So we have y equals 0 minus 1 over 0 squared minus 9. I'm plugging it into our function, our fraction, which is a function. Oop, didn't want to erase that. And then we just simplify. No tricks here. So we have negative 1 over negative 9. And that just comes out to 1 over 9. So our y-intercept is 0, 1 over 9. Now, we might not know where 1 over 9 is. Now, I don't. So when we are going to graph this, we're going to use the decimal form, which is 0.1. So that's what I'm going to graph, 0.1. I know where 0.1 of a thing is, kind of. I kind of know where it is. But I know more about it than 1 over 9. All right, so we have our intercepts. Now that we did our intercepts, we're on to step 4. So step 4 is saying find your vertical asymptote. So remember, your vertical asymptote is just your domain. So our vertical asymptote, we have x equals negative 3 and x equals 3. All right, so we found our vertical asymptotes. Remember, because those are guidelines. We don't cross them. That's why it's the domain. All right, our fifth step, we need to find oblique or horizontal. So we need to use those rules to figure out kind of like what rule do we have to follow. So if we look at the numerator and denominator, the degree of the numerator is 1, the degree of the denominator is 2. So we can say the degree of the numerator is 1 less than denominator. So since that's the case, that's rule number 1. Go back in chapter 5 and you will see those rules. So rule number 1 states that we have a horizontal asymptote at y equals 0. That's what it states. Alright, so we have our first 5 steps down. Now our 6th step. Use the real zeros of the numerator and denominator of r to divide the x-axis into intervals. So we're going to be talking about all of the x values we found. All of the x values. So the numerator, the real zeros of the numerator is the x-intercept. So the real zeros of the numerator, that's just the x-intercept. The zeros of the denominator, that's your domain. So those are all of the x values we found. So we're going to plot all the x values we found on our number line. So we found -3 and +3. And then we also found 1. Now we break it up into intervals. So our first interval is -infinity to -3. Our next interval is -3 to 1. Our next interval is 1 to 3. Our last interval is 3 to infinity. So see how it's like very similar to graphing polynomials? It is. That's why it's kind of lumped together in this chapter. It all starts to pool together for this. So now that we have our intervals, we pick an x in that interval. So a number between -infinity and -3, well, the easiest number is -4. A number between -3 and 1, well, we already have 0, so don't pick 0, because x at 0, we already did it. We did x at 0 right here. That's x0. So instead, I picked -2. You could have picked -1. You could have picked -2.5. I just picked -2. All right, so a number between 1 and 3, that's 2. And then a number between 3 and infinity, I picked 4. So with the x's, you either plug it in to the function. So you either plug it into the function or you use your calculator. I'm going to show you how to use your calculator. That's how I want you to do it. Now, that's just how I want you to do it, and that's the way you should do it. But if you don't feel comfortable, plug it in. Totally fine. It works the same way. It's just going to be a lot harder, a lot longer. All right, so let's break out our calculator. All right, so the first thing we do is to hit y equals. We're going to type in our function, so make sure nothing's there. Type in your function, so alpha y equals enter. We have x minus 1 over x squared minus 9. All right, awesome. Now we go ahead and make sure our window supports the domain. So if we hit the window button, if we look at the domain and all of our numbers, so if we go back to the chart, you see how all our numbers are between -4 and 4? All of our numbers are between there for x's and for y's. So I just want to make sure that my domain on my calculator fits that. Because this part right here, that's the domain. X min, x max, that's the domain. Y min, y max, that's the range. So this, it matches the number. Your numbers do not have to be this. As long as it goes up to 5, you're fine. Now, why 5? Because we have a 4. So that's why. All right, so now that we have it plugged into our calculator, we are going to hit second graph. And we get our x and y chart. So let's scroll up to -4. So at -4, it's -5/7. I'll write it down. I just don't want to switch back yet. At -2, it's 3 over 5. Going to +2. At +2, it's -1 over 5. And at 4, it's 3 over 7. So you see the 3 error, and the up here we had -3 error is because that's the domain, meaning we can't ever plug it in. That's why it creates an error. So if you're ever wondering, like, what is that? That's the domain. Yeah, see? Your wheels are probably turning a little bit. All right, so we plugged in each of these. Now let's write the value. So we have -5 over 7. Now, I don't know about you, but I don't really know where that is on the graph, so I'm going to use the decimal form of -0.7. I know where -0.7 is, it's just a little more of a negative half. All right, when we plugged in -2, we got 3 over 5, and 3 over 5 is approximately 0.6. And when we plugged in 2, we got -1/5, and that's approximately 0.2. And when we plugged in 4, we got 3 over 7, which is approximately 0.4. We have everything we need to graph this. Yep, and it's a lot of work. I love this, though. This is like when graphing gets fun to me. I know, I'm probably the only one, but hey, hopefully you're starting to enjoy it, maybe just a little bit more. All right, so to graph this, the first thing we're going to do is actually fill out our coordinate plane. So the values that we have for the x's are -4 to 4. Awesome. My y's are from like -0.7 to 0.6. So I'm gonna use decimals for my y's, and I'm gonna go by 0.2. So that's 0.2, 0.4, 0.6, 0.8. I don't need to go higher than 0.8 because the highest one we have is -0.7. So I'm just going to mirror it down here. We have -0.2, -0.4, -0.6, -0.8. 8. And I went by decimals because our y values are decimals. All right, now we're going to plot our asymptotes. So our vertical asymptotes we have at +3. Remember, asymptotes are dashed lines. And -3. Then we have a horizontal asymptote at y equals 0. So that just goes straight on the y-axis. Remember, these are guidelines. They're like your borders. You don't cross them. Vertical asymptotes, never cross them. Now let's just plot all our points. So we have an intercept at 1, 0. We have a y-intercept at 0.01, so I would say that's like right here. Then we have points at -4, -0.7. So -4, -0.7, it's about right here. We have -2.6, so -2 and then 0.6. It's right there. Then we have 0.2, so 2 and -0.2, sorry, -0.2, so 2 and -0.2 is right here. And then last we have 4 and 0.4. Remember, so these are going to be guidelines. Where did that one go? It erased itself. Alright, no, we're good. Alright, so in the middle, of course, that's going to be the easiest to graph together and plot together. So let's go ahead and put the middle together. I'm going to use red. So remember, these are guidelines. So I'm coming from here, going to connect the dots, and we just follow it as guidelines. And you follow the shape of it. You follow the shape. So go ahead and like put your pencil down and watch me do this one more time in the middle. All right, so in the middle, if we connect the dots, you see how the natural curve is going down? So we're just going to approach the asymptote. That's what it's there for, approach it. And this one, I already went down, so I need to follow the natural curve and approach that asymptote. Yep, I love saying that. All right. So now let's go ahead and do the one over here. So go ahead and put your pencil down and just watch me do it. Watch me do it, and you can pause the video afterwards. So we approach the asymptote. We're coming from it. Sorry. So we are coming from that asymptote. And we kind of just follow it along as best as we can. That's about right. I mean, on my notes, you'll see it curves a little bit better. But that's, I mean, it's following the asymptotes. I know, it's not the best thing. I can do a really good one over here. Okay, so let's do this one. So we're following that asymptote, and we're going to come up to it. See how it's just our guideline? It's going to take some practice to really start to graph this. Now, if we look at our graph, doesn't it look just like we graphed? Of course, this is a prettier version. So you should always check your graph. You know, you can check it with your calculator, but still graph it by hand. That's a useful tool to know how to graph it by hand. I'm not just saying it to say it. Still graph this by hand. But you can still check it, okay? All right. Let's move on to the next one. Same exact steps. All right, so the first thing we do is factor. Yeah, I'll do it down here. All right, so we can factor the top because it's a difference of squares. So we have x plus 2, x minus 2, and that's all over x. Now let's find our domain. So our domain, its bottom can't be 0, so x can't be 0. And we can't simplify, so we move on to step 3. Step 3, intercepts. So let's do our x-intercept. Remember, x-intercept is top equals to 0. So we're going to use the factored form. We have 0 equals x plus 2, and 0 equals x minus 2. So we have negative 2 equals x, and 2 equals x. So we have two x-intercepts here, negative 2, 0, and 2, 0. Now we find our y-intercept. So remember, no trick for the y-intercept. We have y equals... For the y-intercept, use the original problem. It's just easier. Use the original problem. So we have 0 squared minus 4 over 0. That can't be, because we have negative 4 over 0. That doesn't exist. Also, why doesn't it exist? So this is, it does not exist. Now, why doesn't it exist? When we do the y-intercept, don't we make x equals 0? Is x allowed to be 0? Nope, it's not. So that's why it doesn't exist. But let me tell you the real reason why. It's because of the domain. So the domain states or says x cannot be 0. So we have no y-intercept. So we have no y-intercept. All right. So that is an answer. We still need to list that answer. It does not exist. Undefined, no solution. But does not exist is the, I would say, the correct way to say that, because it doesn't exist. It's not there ever. All right, our fourth step. Let's find our vertical asymptote. I'm going to do it down here. So our vertical asymptote, remember, it's the domain. So x equals 0. Our fifth step, we need to find the horizontal or oblique asymptote. So we need to look at the degrees of the numerator and the denominator. So the degree of the numerator is exactly one more than the denominator. If that's the case, that's rule number 4. Rule number 4 states we have an oblique asymptote. So we need to long divide because we have an oblique asymptote. So let's long divide. We'll have x squared minus 4 inside, and then x on the outside. So let's just go ahead and long divide. We need to make x be x squared, so we're going to multiply by x, multiply it back out. So x times x, that's x squared. We change the sign, and we bring down the negative 4. X can never be negative 4, so our oblique asymptote is y equals x. Now, if you struggled with that, go back to the horizontal and oblique asymptote section, go over long division again. So if you're like, I really struggle with long division, I have videos there for you. All you have to do is just let me know. Or you can just go on my YouTube and you will find it. Or just go to YouTube and Google long division. Not synthetic, long division polynomial. Synthetic is much different, and it's not often used. So just on YouTube, look up long division polynomials, or you can go to my page and find it, or if you want to specifically just do mine and you can't find me, just do long division Corey Milton. I'm the only one on there. But get proficient at the basics. Yes, long division with polynomials is supposed to be a basic step now. So if you're proficient at the basics, we won't struggle with new concepts. So if you have to go back and pause this video, that's cool. That's fine. Sometimes you have to go back and touch it up. You know what I mean? All right. So we did that. We found our oblique asymptote, and let's do our intervals. So we put our x intercepts, so -2 and 2, and then we have another x value at x can't be 0. All right, now we have all of our x values. Let's find our intervals. So we have an interval from -infinity to -2. We have another interval from -2 to 0. We have another interval from 0 to 2. And our last interval, 2 to infinity. Now we pick numbers. So a number between -infinity and -2 is -3. So a number between -2 and 0, of course, you can pick -1. I'm doing this on purpose. I'm picking -0.5. I'm going to show you something, that's why. A number between 0 and 2, I'm going to pick 1. And then a number between 2 and infinity is 3. So you can either plug them in, or you can use your handy-dandy calculator. So let's use our calculator. All right, so if you're here on your calculator or anywhere on your calculator, hit second mode and it'll bring you home. All right, so first thing we're going to do is hit y equals. We need to clear this out, so just hit clear. Now I'm going to type in our function. We have alpha y equals enter, so x squared minus 4 over x. You can see my buttons on the bottom of the screen, so you can see what I'm pressing every time. All right, now that we have that, we're going to hit second table. But you're going to see on the table, how am I supposed to get to 0.5? We chose -0.5. How can I see it? That's why I'm showing you this example. That's why I chose 0.5. So we need to have it change by 0.5. So hit second window. See how it has triangle TBL? That actually means delta TBL, or average rate of change for the table. So we need it to change by 0.5 every time. So you can change that. So say you want to go by 10. So you want your x's to be 0, 10, 20, 30, 40. Or say you want your x's to be 0, 5, 10, 15, 20. You can change that. So I'm changing it to 0.5. TBL start, it is what it is. It doesn't matter what it is. It can be anything. Now we hit second graph. And we have our table. So we have our first x, right, at -3. So we'll just read them. At -3, it's -1.667. At -0.5, it's 7.5. And then we have another one. Come on. At +3, it's 1.667. So we look for our x's on the table and write down our y's. So let's go ahead and do that. At -3, we found out that it's -1.7. Don't have to put a lot of decimal points. It's all graphed by hand, so it's a sketch. At -0.5, it was 7.5. At 1, it was negative 3. And at 3, it was positive 1.7. All right, so we need to fill out our coordinate plane. Let's look at our x's and our y's. So our x's range from negative 3 to 3, and our y's range from negative 1.7 to 7.5. So we just want to keep that in mind as we draw our coordinate plane. So for my x's, I'm going negative 3 to positive 3. And for my y's, I'm going to go to 8. All right, so we have our chart. Now the first thing we do is always graph your asymptotes. So let's graph our asymptotes. We have an asymptote at x equals 0, so that's just straight up and down. Sorry, at x equals 0. Then we have another asymptote at y equals x. So an oblique asymptote, y equals x, it just goes through the origin. Something like this. It's just a line, remember? So the slope is 1 over 1. The y-intercept is 0, 0. That's where we got that from. All right. Now let's plot the points that we have found. So we found negative 2 and positive 2. We don't have a y-intercept. Let's move on to our table. So we have negative 3, negative 1.7. So let's just say about right there. As best as you can. I know it's a little off. It doesn't matter. As long as it's close, you're good. Then we have negative 0.5, 7.5. So that's up there. Then we have 1, negative 3. And 3, 1.7. All right, so we have our chart. Now, I encourage you to just pause it and see if we can connect the dots. Use a pencil. See if you can do it. I hope you tried it. Now, let's see if we can do this together. So to connect the dots, remember, we use our guidelines, our asymptotes as our guide. So we're coming from this asymptote, and we connect the dots and kind of just go out towards it. I'm not the best at connecting the dots. This is actually me trying, okay? All right, so our next one, right, we're coming from the asymptotes, and we kind of just connect the dots. I'm not the best at graphing, but there's our graph. It's good enough. All right, I highly, highly, highly encourage you and hope you do this. I want you to pause it. I want you, no, don't. All right, example 3. You will try example 4 on your own, but let's do example 3 together because I'm going to kind of throw a curveball at you for a second. All right, can we change this to 1, please? Can we do x to the 4th plus 1 over x squared? It just works better that way when we graph it. All right, our first step is to factor. I can't factor anything. It's not a difference, so we can't factor. All right, so since we can't factor, let's go ahead and find the domain. So the domain is bottom can't be 0, so x cannot be 0. All right, awesome, we found that. We cannot simplify either. So step 2, just move on, we can't simplify. All right, step 3, let's find our intercepts. So for our x-intercept, we're going to look at the top. So for our x-intercept, looking at the top, we set it equal to 0. Let's try and solve here, so I'm going to subtract 1. And then I need to take the 4th root because it's x to the 4th. Now, I cannot take the 4th root of an odd or of a negative number. Even roots, it's like this. I can't do that because remember it's I. Yeah, if we haven't talked about that in a long time. So it's the same reason, because that's a little 2. So even roots do not have real values. So meaning, since you can't solve this, you can't solve it. It's no real solution. Since that's the case, there is no x-intercept. It's imaginary. Now let's do our y-intercept. Just going to do it in the same color. So our y-intercept, we need to make x equals 0. We can't though, the domain. So you can't. Why? Because the domain. So there is no y-intercept. No y-intercept. So we have no intercepts. We have no intercepts. Take that in for a second. We have no intercepts. How are we going to graph this? We can do this. We're going to graph it. All right, so let's just keep chugging along. Our fourth step is our vertical asymptote. So our vertical asymptote, remember, it's just the domain, so x equals 0. All right, and now we move on to our horizontal or oblique asymptote. So let's look at the degree at the top and the bottom. So the degree of the numerator is 4. That means, what does that mean? That is 2 more than the denominator. Since that's the case, we have no horizontal or oblique asymptote. Remember that rule? If you're like, where do you keep getting these rules from? I'll show you. Let me show you. So I want to show you specifically where we get this rule from. We're at rule number 4 now, which states the degree of the numerator is 2 or more than the degree of the denominator. There are no horizontal or oblique asymptotes, but we know end behavior. So let's actually do that. Let's find that end behavior. So we can find this, which is very, very thankful that we can, is end behavior. So this is a really good example why we should know how to find end behavior. So end behavior, remember, it's leading term over leading term. So x to the 4th over x squared, which simplifies down to y equals x squared. So if I'm just going to draw that with dotted lines, y equals x squared, it looks like this. That's y equals x squared. That's my, I'm putting quotations, asymptote. It's not an asymptote. It's not. But it is a guideline. It is totally a guideline. Awesome. So we do graph that end behavior because it's going to help us. So we just literally graph using dotted lines x squared. Use a t-chart if you can't remember the points. It's 0, 0, 2, 4, 1, 1, 2, 4, negative 1, 1, negative 2, 4. All right, so moving on to the 6th step, and that is to do our x values. So we only have one x value. It's at 0. So our first interval is negative infinity to 0. And then our next interval is 0 to infinity. So let's pick a number. I picked negative 1 and 1. So with our calculator, let's go ahead and figure these values out. So in our calculator, hit y equals, second window. Let's change triangle TBL to 1. So I want the average rate of change to go 1, 2, 3, 4, so on. After we do that, hit second graph. And now I have my values. So at negative 1, it's 2. And at 1, it's positive 2. So at negative 1, it's 2. And at 1, it's positive 2. All right, let's fill out our t-chart. So we have negative 1 to 2, so we don't need a really big, or coordinate plane, we don't really need a big one. All right, let's plot our asymptote, which is x equals 0, so it just rides this line right here. And now that we have that, and we have our other guideline of y equals x squared, let's plot our points. We have negative 1, 2, and 1, 2. So, alright, just put your pencil down. Let me show you how to graph this. So remember, we have our guidelines, the orange and the purple line. So we're just going to connect this as best as we can. So we're following the asymptotes, following the asymptotes. Same thing here. We're going to follow the asymptote and make our way to the dots back to the asymptote. So what we can do is, if you're a little iffy on graphing, we can go back and check. Don't use it to graph it, but use it to check. And you see, it matches up. All right, moving on. Last example. Before you pause it, I want to switch this last example. I don't like the way it is. So I'm going to switch this example, and then I want you to pause and try it. So I'm going to switch it to 3x squared minus 3x over x squared plus x minus 12. You can do it. You can. So pause, follow all the steps. Don't forget to factor. You got this. All right, I really hope you paused and tried this. Let's do it. So first step, we got to factor. So when we factor, we have r, I don't want that color. We have r equals, we can factor the top because they have 3x in common, so we can take a 3x out. And when we do, we're left with x minus 1. And on the bottom, we can factor that into x plus 4, x minus 3. All right, so we factored it. We cannot simplify. We cannot simplify, so let's go ahead and find our domain. So its bottom can't be 0. So x plus 4 cannot be 0, and then x minus 3 cannot be 0. So we have x cannot be negative 4, and x cannot be 3. All right, so we have our domains. Now we move on to the third step, and that's finding intercepts. So let's find our x-intercept. Our x-intercept, its top equals 0. So since it's already factored, we set each factor equal to 0. So 3x equals 0, x minus 1 equals 0. So we have x equals 0 and x equals 1. So we have 0, 0, and 1, 0. Now we need to find the y-intercept. Do you guys know that if your x-intercept is 0, 0, your y-intercept is 0, 0? And that's because x is 0, y is 0. That's why. You should just always keep that in the back of your mind. All right, so we have our intercepts. Now we move on to either horizontal or oblique asymptote. Sorry, I'm getting ahead of myself. Step 4 is vertical asymptote. So remember, the vertical asymptote is just the domain. So we have x is negative 4 and x is 3. So that's our vertical asymptote. Now we move on to oblique or horizontal. So we need to look at the degrees. So the degrees, we have squared and squared. So they're the same. Since the degrees are the same, we know that our horizontal asymptote is y equals leading term over leading term. So we have 3x squared over x squared, which is y is 3. So now we have our horizontal asymptote as well as y at y equals 3. All right, now we're going to break up our intervals. So we have x values at 0 and 1. And then we also have values at negative 4 and 3. Those are all of our x values. Now let's find our intervals. So our first interval is negative infinity to negative 4. Our next interval is negative 4 to 0. Next we have 0 to 1. 1 to 3, and last but not least, it's a little hard to see, that's okay, 3 to infinity. All right, now we pick numbers in those intervals, so a number between negative infinity and negative 4 is negative 5. A number between -4 and 0, I chose -2. You can choose -3. You can choose -1. I just chose -2. A number between 0 and 1, 0.5, so 0.5. A number between 1 and 3, 2. And then a number between 3 and infinity, 4. Alright, so let's plug this into our calculator. So wherever you are, it doesn't matter, hit y equals. Clear it out, and on the top, so we have a fraction, alpha y equals enter, and on the top we have 3x squared minus 3x, so 3x squared minus 3x, and that's over x squared minus or plus x minus 12. And since we have 0.5s, I need to change the table set. So second window, we need the change of the table to be 0.5. Now we hit second graph, and we're going to list all of our values. So at -5, we get 11.25. At -2, we get -1.8. At 0.5, scroll down to it, we get 0.0667. At 2, we get -1. And at 4, we get 4.5. All right, let's write those values down. So at -5, we got 11.25. At -2, we got -1.8, about, we're rounding. At 0.5, we got 0.07, we rounded. At 2, we got -1. And at 4, we got 4.5. So let's draw our asymptotes and fill out our chart. So we have a big value here of 11.25. So you're going to see I'm kind of just going to have a janky chart and make it work for me instead of writing 11 all the way around. All right. So this is how I did it. I looked at my x's. My x's are from -5 to 4. So I'm actually going to put that. -5 to 4, that's not big. Ooh, wrong color. All right, so -5 to 4. And then my positive y's go all the way up to 11.25. That's a really big number. So I'm going to look at the rest of my positive y's. I have one at 0.07, 4.5, and 11.25. So 0.07, I'm just going to say that's 1. Or, my bad, that's a little low. 1. And then we have one at 4.5, so let's say this is 4. And then 11 is all the way up here. See how we just made it work for us? And then for my negative y's, I'm just going to go negative to -4. Why? I don't know. Just because I want to. And my negative y's, they stop at -2, about -2. Let's plot our asymptotes. We have asymptotes at -4 and 3 for our x's. And 3. We have our horizontal asymptote at y equals 3. So that's about right here. Now those are our guidelines. All right, let's plot all of our points. So we have 0, 0, and 1, 0. All right, then we have points at -5, 11.25, so -5, 11, that's up here. We have more points at -2, -1.8, so -2, -1.8, that's about there. We have another point at 0.5, 0.07, so that's like just dips down just below. See, just dips down as best as you can. Then we have another point at 2, -1. And our last point at 4, 4.5. So let's just say that it's right there. All right. Pause, or don't pause. Put your pencil down and watch me connect the dots. So for the middle, we're going to come from our asymptote and just connect the points as best as we can. and go back to the asymptote. For our left one, we're going to use the asymptote and just make sure we connect that dot following along with it. And for the right one, again, we're coming from the asymptote and we connect the dot to follow along with it. So that's our graph. Of course, you can go back to your calculator and check it. This is for checking purposes. There we go. It is. You can't see it, but it does dip down there. You just can't see it because it's a big window. If you need more practice, what's great is that pretty much we all graph this the same way in the math community. So all you would have to type into like Khan Academy or YouTube is graphing rational equations, and you can get more practice.